Hello everyone, welcome back to the Wireless Communication and the Network Convergence class. After the past few weeks, we talked about network convergence, NGN policy, its challenges, broadcasting, and security. We're gonna start our new journey to the first half of our class name, which is the wireless communication, or as it is the first time we're gonna talk about it, it will be the introduction to the wireless communication. Can now follow me and dare to face the unknown and ponder the question. What is wireless communication? Wireless communication is a type of data communication that is performed and delivered wirelessly. This is broad term that incorporates all procedures and forms of connecting and communicating between two or more devices using a wireless signal through wireless communication technologies and devices. Wireless communication generally works through electromagnetic signals that are broadcast by an enabled device within the air, physical environment, atmosphere. The sending device can be sender or an intermediate device with the ability to propagate wireless signal. The communication between two devices occurs when the destination or receiving intermediate device captures the signal, creating a wireless communication bridge between the sender and receiver device. And then wireless communication has various forms or technology and delivery method, including satellite communication, mobile communication, wireless network communication, infrared communication, and Bluetooth communication. The history of wireless communication started with the understanding or magnetic and electric properties observed during the early days by the Chinese, Greek, and Roman cultures and experiments carried out on the 17th and 18th centuries. The very first will be in 1807, which French mathematician Jean-Baptiste Joseph Fourier discovered Fourier transform. Then in 1895, Guglielmo Giovanni Maria Marconi, who was an Italian inventor and electrical engineer, transmitted and received a coded message at a distance of 1.75 miles near his home in Bologna, Italy. Then in 1897, Marconi demonstrated a radio transmission to a tugboat over an 80-mile path over the English Channel. The first wireless company, Wireless Telegraph and Signal Company, was founded. They bought most of Marconi's patents. Lord Rayleigh suggests EM wave propagation in waveguides and analysis of propagation through the electrically filled waveguide. Lodge patent various type of antenna, which two electors send the first international wireless message from Dover, England to Limerick, France. Then in World War II, many advanced military radio systems were developed. Portable radio sets were provided as far down in the military echelon as the platoon. In every tank, there was at least one radio, and in some command tanks, as many as three. Radio relay, born of the necessity for mobility, became the outstanding communication development of World War II. Sets employing frequency modulation and carrier techniques were developed and used, as were also relay sets that use radar pulse transmission and reception techniques and multiplex time division methods for attempting many voices channels from one radio carrier. Then comes Wi-Fi, that enjoying tremendous success and growth with Bluetooth and satellite also widespread. Next, the future of wireless network. Buildings, vehicles, and smartphones are all connected and communicate with one another, as shown in the image. It depicts how the network in the future is imagined by the public. The Internet of Things or IoT is a component of future wireless network. The future wireless network aims to provide pervasive wireless connectivity to all objects capable of transmitting and receiving signals. We can build a smart home atmosphere with smart home furniture, allowing us to control lights from our smartphone, monitor our security cameras from our phone, and so on. Other than that, we can also design smart cities in which all buildings can talk with one another and where devices are connected even within the structures. This structure can be connected to a 5 net with similarly high expectation for wireless network in the future. And now here comes the challenges. Here comes the challenges. Do 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 do. And I say it's alright. Well, it creates new challenges. And like the past few weeks, I will explain to you about the challenges and its solution. First is the network or radio challenges. It is divided into 6 challenges. The first one is Gbps or gigabit per second. Data rates with no error. It is essential to provide a high level data rate with fewer error presentation. People enjoy the high definition video, which require a higher data rate. So a higher quality files mean a higher data rate. The second one is energy efficiency. Nowadays, people use more than one telecommunication device, and it needs to be powered by electricity, which leads to increasing usage in electricity resource. So the device needs to be more efficient or get better battery or etc. The third one is the search bifurcate spectrum. The spectrum wave used for wireless connection is limited, and its telecommunication technology has designed for a dedicated spectrum. The fourth one is reliability and coverage. Reliability means the ability of the system to provide a good service. Coverage means somehow the network technology should provide a wider area or a whole country. A wider coverage area can gain more users. The fifth one is heterogeneous network. A heterogeneous network means that there are different types of network technology such as 3G, 4G, 5G, Wi-Fi, Bluetooth, and etc. that need work seamlessly in one place. And lastly is the seamless internet network handoff. Seamless internet network handoff means that sending service to another BTS or base transceiver station, it is essential so that the user can call a person from areas far away seamlessly without interruption. This is the challenge that happens since you are disconnected from BTS in your region and redirect to another BTS near the destination area. Next challenges is the device or COE, which is the system of flips challenges. As you can see here, these are the main components of a smartphone. There is a Bluetooth module, memory module, CPU, radio module, GPS module, Wi-Fi module, and etc. The smartphone must have good performance in order to support advanced technology and a good user experience. Then is complexity. Things inside the smartphone are getting more complicated since the size of the components are getting small as time goes by to give a compact smartphone design with advanced technology. Then the challenges lie in the size, power, cost, and energy. With the high frequency and millimeter wave, nowadays people want to get a high data rate, as I said before, and it can only be provided by high frequency. The millimeter wave deliver high frequency. To deliver high frequency, it needs multiple antenna configuration. In current generation smartphone, there are 2x2 antennas configuration. It means that there are 4 antennas inside our smartphone. Then the multi-radio integration means multi-work frequency. Our smartphone can be used for radio, Wi-Fi, GPS, and etc. And lastly, it's coexistence. The smartphone still needs to coexist with older technology. For example, our smartphone is 4G based network, so it should be able to use 2G and 3G network. Well, that sure is a lot. if only we have a solution for that, right? What we do have a solution for that? Okay, the solution is first one is software radio. This technology makes radio not only for one module but can be seen as software. The DSP, digital signal processor, can be programmed so that can be used for any technology, 3G, 4G, 5G, and etc. With this technology, we can generate a high spectrum bandwidth of this. And next is the channel limit. It is a measurement of our network capacity. In other words, it refers to the maximum amount of data that may be transmitted over distance. We can see the bandwidth, which is B, transmission power, which is S, and noise, which is N in this formula. The S per N ratio can alternatively be expressed as S and R, signal to noise ratio. We can send and receive more information when high power is employed and vice versa. More important, more important information can be placed when the bandwidth is great and vice versa. We can construct modern communication technologies thanks to the Shannon theorem. Next, we're gonna talk about the current and next-gen file system. For the current, there is 4G LTE, 6G LAN, and Wi-Fi, millimeter wave, and massive MIMO, ZigBee, and Bluetooth. And for the next gen, there are 5G and 6G, 7G, LAN and Wi-Fi, cognitive radio networks, energy harvesting system, chemical or molecular communication. Then that's all for this week. We're gonna see you again. Thanks for watching.